second part of our community spotlight, let me introduce Luliana. Luliana was one of the winners of the recently completed Ludwig 10,000 GitHub stars
Congratulations.
competition. Yes, congratulations. And Luliana built a use case with Ludwig on the healthcare topic, assessing healthcare data, becoming more aware. So Luliana has agreed at her very late hour to come and give us an informal presentation about her project, her data set, and her challenges, her wins. And everybody can come and contribute to whatever Luliana needs to continue with that work. So please give a warm welcome to Luliana.
Thank you, Luliana, for giving the talk.
Thank you for the opportunity and for the introduction. So I will share my screen. I prepared a small presentation. Can you see the right screen? I hope with the presentation.
Yeah. Yeah.
Okay, perfect. Okay, so I already presented myself a bit. So as I said, I'm a backend engineer and also an artist, and I'm also passionate about health aspects and sport in general, and to discover new things about these domains. So I will start with the project that I made for the contest. And the first step was to collect the data. So for this, I used the smart ring, which is an Oura ring, and I collected the data from myself. So it's a personal data. And this is why at the moment it's a small data set, because I started to acquire data in October, so I only have the data from October and until now. So here is a snapshot of the data. So we have the date, the deviation temperature, which is the temperature of the body and how it goes up or down from the normal temperature that my body has. This is the start date. So this is the start date of the period I used. So this will be binary. So 0 means it's not the start date. So yes, this is the resting heart rate, and this is the daily readiness. And I will go into more details about what is a bit later. So this is how the data was collected through an API call to this URL, and then I'm taking all these features that I thought were interesting and useful, and creating my own data set. So how this started? So as I said before, with the dataset creation, but also with the idea on where to go. So after I created the dataset, so in the initial step, it was a bigger dataset with more features. But then I studied a bit the data to see exactly what I need. I used some plots and some analysis. And after I identified the most important features, I used Ludwig to train the model. And then after the predictions, I used some more plots to see if the predictions were what I needed and if they were accurate enough. So you can see these are some examples of the plots that I did. This is with the resting heart rate, with the dates, and this is with the temperature deviations. So here comes the configuration. So as I said before, I used a small data set. So for this case, I used only 10% of the data as test, and this is still work in progress to build on the data. So as some input features, so I used the time series data, and I use the deviation temperature, the daily readiness, which is a sum of these contributors. So this means how ready I am for the day. So for example, if I slept well, if my body temperature is within the ranges, and if I recovered well from the activity that I had before, it will be a good score, if not a bad one. And also, this is the period start date, which I said, as I said before, it's in binary format. So what I wanted to do
Maybe one thing I
was
have a little question, Juliana. I'm curious, those were the input features that you were using, but what were you
yeah,
trying to predict? Were you trying to predict the time series in the future, or were you trying to predict like the daily readiness for the next day or something like that?
yes. So what I wanted to predict was the deviation temperature and also the start date of the event.
Ah, okay, so those were actually within the output features, not the input features. Got it.
Yes, yes,
I see. So
yeah.
Okay, I got it.
Okay. So what I wanted to do was to integrate all the work into a pipeline so that I can scale it and I can reconfigure it if needed. So this was done using Mesh.ai. So we can see here the data is loaded from a CSV file that I created. Then the data is prepared by splitting into the training, into the validation and test. Then I'm creating the Ludwig model and then the predictions and the plots. So what I wanted to do was to be able to predict the data, but also adjust the models in the meantime. So this is why I used MLflow and MinIO to store the models. So you can see here this long thing. This is the ID of the model. So every time I train a new model with some new data, I can store it and then I can use it and I can see if the predictions were improved or not. So if the predictions weren't improved, I can go back to the previous saved model. So this is what I use Ludwig for to predict, for example, the data for the next 30 days. So I can predict the deviation temperature, also the daily readiness, and also the start of the event. And so as the start of the event is binary, I use the maximum start date probability to assess that this will be the start of my event. And also I was interested in the maximum deviation temperature because as from what I researched, the start date of the period is highly linked to the an increase in deviation temperature. And then later I can continue this analysis to shorten the time frame of the predicted time. So at the moment it's from this red dot to the blue dot, but later I can continue. So what I also did was I compared the results, for example, for the daily readiness, to see how well the model performed. So this is the data that I used, the historic data, and you can see the red line is the actual data, and the blue one is the predicted one.
This is very
So
It looks like there's the model gets it mostly right, but doesn't get the extreme cases, right?
yes, it tries, for example, here it tries to follow it, but it's close a bit.
Yeah, the more far you are from the standard deviation from the base value, further the model drifts, right? But when you are closer
Yeah.
to the deviation, it's like so it's kind of capturing the general trend decently well. It's not capturing the exceptions super well, I guess.
Yeah, so I thought maybe I can extend it and also catch the anomalies or the outliers because maybe it was something in this data point. So I can do something about it.
Got it. Got it. So you think that there's something in the sensor or like this capturing like an extreme version of the value to begin with, right? Interesting.
So the event in this case that I used is the start of the period. So it depends on the subject which is studied. So I don't know.
Okay. I mean, it's even on a small data set, the predictions are pretty good. And on a larger one, we might even get even anomalous cases, or if there is any modification to the model parameters and other hyperparameters, you could get even farther.
Okay, so I have this one last slide where I thought about the future. So what I would like to do. So I would like to get more data, of course, and to explore on other subjects as well, not only on myself. And I want to gather more insights into the connections of the temperature deviation. And also what I said before regarding the anomaly detection, maybe. So thank you so much for your attention. And if you have any questions, you can also ask them now, or you can also contact me anytime.
Thank you so much for the presentation and for working on this, Juliana. This is super cool. In fact, that
Thank
you
you.
make your own data, I think it's very, very, it's amazing. It's like not always the case. People usually search for some data around the internet or whatever, but in this case, it's like your very personal data. So it's like, I don't know, I find it very fascinating.
I've heard that too in the case of health devices. Researchers start with their own data, and then they see something interesting and it goes on from there. So,
Makes
yes,
sense.
I would like to second Piero, and on behalf of everybody, thank you for entering competition, learning Ludwig, working on data set collection and cleaning and all of those charts that are needed for feature engineering, producing the results and coming to us to present. Really appreciate it. Congratulations.
Nice.